Hello students. So today discussion from the ninth toppers, the discussion is about law of chemical combinations. So this chapter is very important students in terms of how the chemicals are combining, what are the rules which are followed by these chemical combinations, everything. So in this video we are going to discuss about law of conservation of mass, law of constant proportions. Okay. So first of all to start the discussion, law of chemical combinations. Okay, there are some laws which gives certain rules and guidelines for these chemical combinations. First of all, what is a chemical? Define a chemical, students. A chemical means anything is a chemical. Yes or no? Are you still thinking like chemicals are some colorful substances which are found in the lab? No, water is also chemical. So that's why you're saying chemical formula of water is H2S or no. So when these chemicals, that means chemicals means in general substances, elements or compounds are chemicals, right? When these elements or compounds are combining, how do they form a chemical formula? In what ratio they combine? In what ratio they combine? By weight, by atoms. What are the chemical combinations? Is there any change in the weight before and after the reaction? So all these points are explained by certain laws, and these laws are called as laws of chemical combinations. So first of all, to start the discussion, introduction, chemistry is the study of transformation of matter from one form to the another form. Yes or no? A matter, anything which has mass and occupies space, can be converted from one form to the another form. Hydrogen is a gas, oxygen is a gas. When they combine, they produce as water. Yes or no? Hydrogen is a combustible gas, oxygen is supporter of combustion, but water stops the combustion. Understood? A matter, ultimately all are matter only, but it changes from the one form to the another form. In this transformation, what are the principles which the chemicals participate during these reactions? What are the principles which are accepted by these chemicals to undergo all these reactions? They are given in certain laws, and these laws are called as laws of chemical combinations. Chemical combinations is when they combine to produce a new substance, right? Chemically. So these transformations often occur as a result of the combination of two different types of matter. The combination of different elements to form compounds is governed by certain basic rules. Some very basic rules are there. These rules are referred to as laws of chemical combinations. Total there are 5 basic laws of chemical combinations. In this video, we'll focus on the first 2. To start the discussion, first of all, law of conservation of mass. For example, students, the reaction which we discussed, hydrogen combines with oxygen produces water. Okay, a new chemical is synthesized. Answer, is there any change in the weight of the chemicals which are combined and the product which is produced? Is there any change in the weight? Like a new weight is getting synthesized or some weight is getting destroyed? What's your idea? An apple grows, a new mass is it created, any new matter is created. A small seed grows into a big tree. Anything new matter, new weight is getting created? What's your guess? The answer is no. Matter can neither be created nor destroyed. That is law of conservation of mass. Matter can neither be created nor destroyed. It simply changes from one form to the another form only. That means the reaction, the weight of the reactants and the weight of the products after the reaction are absolutely equal. There is no loss of weight, there is no excess gain of weight. That means weight is not getting destroyed or weight also not getting newly synthesized. No, matter is not getting destroyed and the matter is not newly synthesized. It is simply changing from one form to the another form. It's same matter only. It changes from one form to the another form. In simple terms, this law states that matter can neither be created nor destroyed. Yes or no? An apple is growing, sir. A new thing is, yes, new thing, correct. But how it is growing? It is utilizing all the nutrients from the soil. Yes or no? They are getting converted into a new chemical. Ultimately, new matter is producing. No, new chemical is synthesized. That's it. Matter is same. From nutrients, from the soil nutrients to it produces a new compound which is useful for us. Yes or no? So that's what the point says. Matter can neither be created nor destroyed. It simply changes from one form to the another form. So in other words, the total mass, that is the sum of masses of reacting mixture and the products forms remains constant. That means in a chemical reaction we have two terms as students to define a chemical reaction. to define a chemical reaction. Reactants and products. Reactants means which participates in the reaction. Products means which is synthesized in the reaction. That is a product. So in this reaction, the weight of the reactant is always equal to the weight of the product. So it was given by the scientist Antoine Lavoisier, gave this law in the year 1789 based on the data he obtained after careful studying of numerous combustion reactions. What are combustion reactions? Burning reactions are called as, students, combustion reactions. So let's see some examples on this. So students, see, this law can be verified by the study of any chemical reaction, right? Correct. Not only a single, all the chemical reactions should obey law of conservation of mass. Why? Because the mass before the reaction, after the reaction is absolutely same. That means the mass of reactants and the mass of products is absolutely same. We have a reaction here. The reaction between silver nitrate plus sodium chloride gives rise to silver chloride plus sodium nitrate. This is a double displacement reaction, students. Comes under precipitation reaction, okay, insoluble solid. So answer, the mass of these two components, which is silver nitrate and sodium chloride, is it equal to the mass of these two compounds? These are new products, yes or no? These are the reactants. Are the masses equal? And that's what the law is, yes sir. The masses are absolutely equal. The mass of reactants are equal to the mass of products. That means these reactants only converting into new product, yes or no? Is there any change here? Nothing. A new chemical is synthesized, that's okay. But matter changes? No. Matter is changing from one form to the another form, that's it. Ultimately, is it destroyed? Is it created? No. Got the clarity, students? So we have a simple experiment for this. When a solution of silver nitrate is treated with solution of sodium chloride, a white precipitate, which is silver chloride precipitate, is obtained, students, along with the solution of silver nitrate. If the law is true, the total mass of AgNO3 and NaCl should be same as the total mass of AgCl as well as NaNO3 solution. This experiment is done in a specially designed H-shaped tube called as a Landau's tube. It looks like this. Here in this first one tube, we have a solution of silver nitrate. In the second tube, we have sodium chloride. We have to measure the weights of both the tubes. Okay, let's say both the tubes weight is X. Okay, now are they reacting? No, independently are there. Okay, now if you invert the tube, inverting the tube, then what will happen? You can see there is a connection tube here, yes or no? These chemicals, if you invert, these chemicals combine in this, yes or no, students? If they combine, what will happen? Look at the reaction, previous reaction, AgNO3 plus NaCl gives rise to AgCl plus NaNO3. A chemical reaction happens. Now after the reaction, measure the mass of the chemicals which are in this tube. Now, what is the mass of the chemicals after the reaction? X only. That is law of conservation. This is an experimentally proven. There is no chance for assumption. Got the clarity, students? That means ultimately the mass of reactants is equal to the mass of the products. There will be absolutely no change. That is law of conservation of mass. Matter can neither be created nor destroyed. But what is happening, sir? New thing is producing here, right? Correct. A new chemical is getting produced. From where it is produced? Is this chemical giving birth to new chemical? No, right, students? These are only the bonds were changed and they form a new species. That's it. Understood? Got the clarity? So we have one more example. Consider the formation of water molecule H2O. Hydrogen combines with oxygen to form water molecule. Look at this reaction, students. Clearly this reaction is given in terms of atoms and molecules. See here, this is hydrogen molecule. Yes sir. Now what is the formula? H2. Two hydrogens are there, right? This is one more hydrogen. That means 2H2 plus, and this is O2 gives rise to, what is this? H2O. 2H2O. This is the reaction. Yes or no? 2H2 plus O2 gives rise to H2O. How many hydrogens are there? You can count in the molecule. In one molecule, how many? This is one, this is second, this is third, this is total 4 hydrogens are there. Yes or no? Let us count the number of hydrogens on the product side. 1, 2, 3, 4. Same number or not? Is there any change? Any hydrogens gone? No, right? Now let us count the number of oxygens. Here 1, this is the second one. This is the one, second one. Now ultimately, students, the number of atoms which are there on the reactant side are equal to the number of atoms which are there on the product side. Atom has a mass. If number of atoms are same, mass will be same, right, students? Before the reaction, after the reaction. That is law of conservation of mass. So clearly in this slide, The masses were given. The mass of one hydrogen atom is precisely, not approximately, precisely 1.008 grams. So in a single molecule, how many are there? 2 hydrogens are there. So 2 into that number, how much we got? 2.016 grams. So total how many molecules are there? 2 molecules are there. 4 atoms are there. Yes or no? Ultimately. So 2 into that number, which is 4.032 grams, is the mass from hydrogen side. Next, oxygen mass is 15.999. So how many are there? 2 are there. So 2 into that number, how much we got? 31.998 grams from oxygen side, O2. Now add all the masses, hydrogen masses and oxygen masses. So how much we got, students? 36.030 grams. Okay, clear? Now we have the molecules on the product side, H2O, H2O. 2 hydrogens, 2 into 1.008 plus 15.99. How much? 18.015 grams for one molecule. Obviously same mass for another molecule. Yes or no? Now 2 into that number, how much, students? How much we got? 36.030 grams. Is there any change in the mass? How it will change? Is there any change in the number of atoms? Sir, molecule is changing, yes, molecule is changing, combinations are changing, that's it. Are the number of atoms gone? Number of new atoms created? No. Ultimately, number of atoms in a molecule is same. Number of atoms in a reaction is same before the reaction, after the reaction. The mass is also same before the reaction, after the reaction. Got the clarity, student? This is law of conservation of mass. So, these are examples. Next, law of definite proportion. This is also one of the main law which explains the chemical combinations. Law of definite proportions, there is one more name called as law of constant proportions. This law states that, students, a fixed compound is always have fixed weights. What is the law of definite proportions? A compound always combine the components by a fixed mass. For example, carbon dioxide. What is the formula? CO2. Yes or no? This will explain in terms of weights. Of course, by atoms also. Carbon's mass is 12 grams. Oxygen 16. 2 are there. 2 into 16, 32 grams. So in CO2, from carbon 12 grams is combined with 32 grams of oxygen. Yes or no? Now, carbon dioxide in America. What is the formula? CO2. Carbon dioxide in different continent. What is the formula? CO2. 12 grams and 32 grams. Carbon dioxide in Mars. What is the formula? CO2 only. 12 grams of, yes or no? 1 carbon, 2 oxygens everywhere. Carbon dioxide in Venus planet, or carbon dioxide in a different star system. Everywhere it is CO2 only. That is only carbon dioxide. That's what law of definite proportions is saying. Always a compound combines in a fixed composition by mass. Joseph Proust is a scientist, a French chemist, stated that the proportion of elements by weight in a given compound will always remains exactly the same. In simple terms, we can say that irrespective of its source, origin or its quantity, the percentage composition of elements by weight in a given compound always remains same. That means the carbon or oxygens in CO2 everywhere same. The number of hydrogens and oxygen in water everywhere it is same. Understood? By weight, of course, by atoms or by weight. If the compound AB is found by the two different methods, and in the first method if m grams of A combines with n grams of B, and in the second method if x grams of A combines with y grams of B, then according to this law, m by n is equal to x by y. That means the ratio in which they combine is equal to same. Understood, students? For example, sir, I prepared 100 grams of carbon, I am taking 100 grams of carbon, I am taking 200 grams of oxygen. In other case, I am taking 50 grams of carbon, I am taking 100 grams of oxygen. Do we get the same? Yes, you will get the same CO2. Maybe if you are taking extra mass, you will get extra molecules. Does it change in the mass in a single molecule? No. You are taking 100 grams, so one carbon weighs 100 grams. No. Understood? Got the clarity? If extra mass, if you, extra sample you are taking, you are getting more molecules, that's it. But if you consider one molecule, CO2 is everywhere, CO2 only. Take any grams, CO2. Got the clarity, students? By mass. Of course, this law is explained in terms of mass. Carbon's mass is 12 grams and oxygen 16. 2 are there. 2 into 16, 32 grams in CO2. Okay, 1 mole. Right. Example, students. Carbon dioxide is made up of 2 elements. Okay. Carbon and oxygen, which is always present in the same proportion, 12 is to 32. Yes or no? Carbon's is 12 grams, 32 from oxygen, O2. Oxygen 1 is 16 grams. So, CO2. That is, if you simplify this expression, this ratio, 3 is to 8 by mass. Thus, 44 grams of carbon dioxide is composed of 32 grams of oxygen and 12 grams of carbon. So thus we see that law of constant proportion is true regardless of the source of the sample, which may be obtained from the natural source or prepared artificially in the lab. If you extract CO2 from the nature, or if you synthesize CO2 in the lab, what is the formula? CO2. In that CO2, carbon's mass is definitely 12 grams. So, sir, I am taking extra mass, so carbon is a big no. Is it getting no? 100% no. Everywhere carbon is 12 means 12 grams only. Oxygen is 16 grams only. 2 are there, 2 into 16, 32. That's why I mentioned CO2. Na? Next example. We get a water from different sources, from rainwater, streams, lakes, springs, wells, tanks, rivers, sea. We have different sources of water, as students, from oceans, from sea water, from rainwater, from lake, ponds, from streams, springs, all the water. Is there any change in the formula? No. H2O. In all these examples, hydrogen mass is 1 gram approx. Oxygen mass is 16 grams approx. Sir, no. That means 2 hydrogens are there. 1 plus 1 plus 16, 18 grams is the molecular mass of H2O. So students, but in each case the water contains the same elements, hydrogen and oxygen, combining in the ratio of 2:16, which is simplified is 1:8 by weight. The irrespective of the source and the method of preparation of water contains the same elements combining in the same constant proportion. That means students, everywhere collect the sample of H2 everywhere. They are always in the same ratio. What is the ratio? By atoms 2:1, 2 H2O, yes sir, 2 hydrogens, 1 oxygen. By mass, what is the ratio? 1:8, 2:16, yes sir, simplify 1:8. That is law of constant compositions, law of constant proportions. A given chemical compound, everywhere collect the sample, always it has a fixed composition by weight, is law of constant composition. That's all for students about these 2 laws. We have 3 more laws that we'll discuss in the next video. Thank you, students.